Introduction to Kubernetes. Kubernetes can be defined as an open-source container orchestration platform that automates many aspects of deploying, scaling, and managing containerized applications. It provides a framework to manage and schedule containers across clusters of machines, providing efficient resource utilization and high availability. In this part of the course, we will provide an overview of Kubernetes. Kubernetes offers a range of features that simplify the management and deployment of containerized applications. It provides a unified API to control and monitor the state of applications and leverages automation to scale applications based on resource utilization. Kubernetes also supports fault tolerance, self-healing, and load balancing to ensure the availability and reliability of applications, automation, and resource utilization. Kubernetes automates many aspects of application deployment and scaling, enabling efficient resource utilization. It automatically manages the placement and scheduling of containers, ensuring optimal usage of available resources, availability, and fault tolerance. Kubernetes provides fault tolerance and availability features to ensure that applications are always accessible. It supports self-healing mechanisms, automatic container restarts, and load balancing across multiple replicas, preventing single points of failure. Declarative application deployment. With Kubernetes, application deployment is defined declaratively using YAML or JSON manifests. This approach allows users to specify the desired state of their applications, including the number of pods, container images, and resource requirements. Networking and service discovery. Kubernetes has a flexible networking model that assigns a unique IP address to each pod. It provides DNS-based service discovery, allowing pods to communicate with each other using domain names. Load balancing across multiple pods is also supported. Scheduling and scaling capabilities. Kubernetes offers powerful scheduling capabilities to optimize resource utilization. It supports different pod scheduling policies and allows users to define affinity and anti-affinity rules for pod placement. Automatic scaling based on CPU and memory utilization is also built in. Zero downtime updates. Kubernetes handles application updates with zero downtime. It supports rolling updates, gradually deploying new versions of applications while ensuring that a certain number of old versions are still running. Canary deployments are also possible, allowing for testing of new versions before full rollout. Extensibility and integration. Kubernetes is highly extensible and integrates with various tools and platforms. It supports plugins and configurations for monitoring, logging, load balancing, and storage solutions, providing a comprehensive ecosystem for managing containerized applications. One of the essential concepts in Kubernetes is the notion of a pod. A pod is the basic scheduling unit in Kubernetes and represents a single instance of a running process. Pods can include one or more containers that share resources and network, enabling them to interact with each other. This enables easy deployment and scaling of multi-container applications. The Kubernetes architecture consists of several components that work together to provide a highly available and scalable platform. The control plane, which includes the API server, scheduler, and controller manager, manages and controls the overall state of the cluster. Worker nodes, also known as minions, host the pods and containers and execute the workload. Kubernetes provides a declarative approach to application deployment. Users define the desired state of their applications through YAML or JSON files, known as manifests. These manifests describe the desired number of pods, the container images, resource requirements, and other configuration details. Kubernetes then ensures that the actual state matches the desired state. Kubernetes uses a highly flexible and extensible networking model to manage communication between pods and services. It assigns a unique IP address to each pod and provides DNS-based service discovery to enable inter-pod communication. Load balancing across multiple pods is also natively supported. Kubernetes provides powerful scheduling capabilities to optimize resource utilization. It supports different pod scheduling policies and enables affinity and anti-affinity rules to control pod placement on nodes. It also supports automatic scaling of pods based on CPU and memory utilization. More specifically, Kubernetes offers various scheduling policies to optimize resource utilization. Users can define affinity and anti-affinity rules to control pod placement on specific nodes. This helps in achieving better performance and resource allocation. At the same time, Kubernetes supports automatic scaling of pods based on CPU and memory utilization. It monitors resource usage and adjusts the number of replicas to ensure that applications have enough resources to operate efficiently. Kubernetes enables zero-downtime application updates through rolling updates. It gradually deploys new versions of applications while maintaining a certain number of old versions, ensuring continuous availability for end users. Kubernetes is an extensible platform that supports many plugins and configurations. It integrates seamlessly with other tools and platforms, such as monitoring and logging systems, load balancers, and storage solutions, providing a comprehensive ecosystem for managing containerized applications. To summarize, Kubernetes is a powerful container orchestration platform that simplifies the management and deployment of containerized applications. It offers a rich set of features including pod scheduling, networking, automatic scaling, and rolling updates. When using Kubernetes, organizations can benefit from increased efficiency, scalability, and reliability in deploying and managing their applications.